So instead of binary regression, log regression, we're going to try multinomial. It's only going to have 3 categories, which will make life a little easier. Now the interpretations and the output will look very similar. It's just that the mlogit package has this like special formatting you have to do, which once you like get an idea of what it's doing, it makes sense. But don't read any of the help guides online because they're quote so very helpful, which must be sarcasm for this is not in English. I finally found a YouTube video that explained it. I was like, yes, thank God for YouTube. Right. So we're trying to predict the difference between anorexia compared to patients with bulimia or both. So if I have, I know it seems weird to have both, but they have different symptoms. So can I correctly predict patients one or the other? Right. So their diagnosis is either anorexia both or bulimia after anorexia, but we're just going to call it bulimia to make it easier to interpret. And we have a bunch of different scales. So these are like perception scales. They're not actual weight. So weight being like I'm very concerned about my weight. Fasting, binging, vomiting, purging, hyperactivity. So things you don't want to talk about after lunch. Right. Preoccupation with body weight, and then body views, just the way they perceive their body. So 4 is a bad scale on this scale, whereas 1 is on the good end. So just a kind of reminder, power is the same thing as regular regression. So under test family, it is F. Statistical test is regression, deviation from 0. I think I did small, so I'm going to hit determine from correlation 0.01. I'm amazed at the number of participants. 0.05, 0.80, and the number of predictors I actually have is incorrect. It's the number of IVs, but we'll talk about why that's not actually right here in a minute. So I think it's 8. Right. It is 8 per equation. It's actually 16 total. So that gives me 1,500 participants. So for each comparison, anorexia to both, anorexia to bulimia, it would be 8 predictors, but this is going to give it to us in all one big giant equation. It's actually 16 predictors. But we would test it assuming at least one of these equations is going to work. So if we did 16 predictors, oh my God, it's going to be crazy. 19, 21. So let's hope the power is bigger than that. The data screening is all the same. So we're just going to look and make sure that the scale runs from 1 to 4 like we would expect it to, and that our DB is categorical, which at the moment isn't. So if I run my summary function, where is the factor code? Oh, it's up here. If I look at each one of the variables, they're all 1 to 4, or 1 to 3, which is good. So nobody's outside the range. This is a clinical sample, so they're all really close to the top, right? So they're all in the scary range, so close to 3.75. But my diagnosis variable at the moment is 1 through 3. So we need to make sure we change that to a categorical variable or none of the rest of this will work. So I did that on lines 11 through 13. Since here it's a mean, I don't know what my ratio of cases is. So that's the other, the first kind of assumption is that my ratio of cases isn't too crazy, so I reran it. And the both group is going to be really hard because it's 3 times less than anorexia. So trying to predict both is going to be difficult because it's way less. 5 times is where it becomes like nearly impossible. So we can try it, see what happens, but percent-wise, both is going to be probably the lowest, just because we have the least number of people to estimate from. All right, so my number of cases, we did all this. So quick note, since this is multinomial, it's actually going to dummy code the DV. We've talked about dummy coding the IV. Now you're actually going to dummy code the DV, which will look like it's dummy coding the IVs, which we'll get to in a minute. So essentially what happens, squeak, is that we're going to get one equation that is anorexia versus both, and then one equation that's anorexia versus bulimia. Because that's dummy coding the DV. So we talked about dummy coding being like everything versus a control group, and you get levels -1. So 3 levels, I get 2 comparisons, but then it's going to test each IV on that dummy coded DV. So while this output is one giant set of output, it's much easier to think about it as 2 separate equations. So let me write down all the variables real quick. So we're going to look at weight, fasting, binging, moment, purge, hyper, this preoccupation is prio in the data set, and then body. And we'll get each predictor for each DV. It doesn't give you 2 separate equations. That would make life a little easier. It gives you each one of these variables with a label next to it, which one it goes with. And then it tests them all together as one giant equation. All right. So I could use, I could change and make my reference level a different one. And the nice thing is I wouldn't have to refactor it. There's a little line in mlogit that's ref level. So you can actually change it to not be the alphabetical first one. At the moment, that's what we want. Because it's sort of like anorexia all by itself to both or bulimia after they've had anorexia. So it makes sense as the comparison group. But if I wanted to switch and do both versus bulimia, I could just change one little piece in the mlogit code. Okay, so I don't have any missing data. Woohoo! Next time we're going to talk about EFA. I love EFA. And we'll get to estimate missing data again. You understand? Like, it's my favorite. So, anyway, that aside, let's look at correlations. So the -9 is because that is my DV. So I'm taking out the categorical variable. I have 1 comma that I missed when I was making the notes. So if I look at it, where are you at?
2 commas.
Two? Can I not see? Well, is it okay? 2 commas then. So here's 1. It's 0.6, 8, so it's close. Purging and binging, not too surprising. Where's you?
Wait, now it's up in the top corner.
Wait.
Very top corner. Top left. Second from the top.
Oh, there. Here. Yeah, 0.6. That's okay. Yeah, these little commas are hard to read. Oh, I see it now. I can't blame it on being late because it wasn't. I was even drinking coffee. But anyways, they seem okay. We do have some potential suppression, but if you look at the whole chart, they're below 0.7. Okay, so be sure you have mlogit installed. Now I'm going to run the library. And so what we've been doing, let's look here. So this is before. This is how the data set's laid out right now. This is wide format. We've talked a lot about wide versus long all year. And generally for regression, wide format's what you want. You don't really want long format. And the issue with this package is it has to be in a slightly different version of wide-ish long. I don't know how to describe this. So what I have is for each person, I have their actual diagnosis. Instead, what it wants you to have is for each person to have a true or false for each diagnosis in long format. So kind of what they want, really brief, I'll write it over here, is for us to have 3 columns and to code it in a dummy coded style. So yes, no, no. So for all participants that have each one, no, you're fine. I saw it there and then I clicked on it. To have a true false for each one. That would be in wide format though. So it wants it in long format, which is just a pain. So this package has a special wide to long conversion where it'll stack it like the after in the notes. So all this is the same. We're leaving that alone because that one needs to stay. This diagnosis column changed to a true false. So for the first person, they were anorexic, so it stayed true, true, true. CHID is the participant number. And then it has all three diagnoses and has just like true, false, false, true, false, false. I don't know why. It just like that's the format it has to be in. It also changed the row numbers over here. So this is still participant 1, 2. So each person gets 3 lines. Okay. And essentially that's long formatted dummy coding. We're finally like conceptually got. So we're just marking what category they're in and every other category they're false. It uses reshape in the background, but it was much easier to understand the code for mlogit than it was to reshape in this format. So what happens? Well, I'm on line 28, so it's mlogit.data, so we're setting up the data. And don't look at, like I said, don't look at the help guides online. Just don't. For the first piece, it needs to be the dataset name, comma, choice. Choice is what's the DV, what's the categorical variable. So I said diagnosis here. And what shape is it already in, and then wide. So the first one is dataset. This is ED with a categorical thing in it, and then shape is always going to be wide. Online, they have a bunch of talk about the word varying. So it'll say varying equals, and it looks like you should just dump all of your columns in there. Lies. Okay. So there is extra code if you have what's called doubly repeated measures. So let's say we took weight at time 1 and weight at time 2 and weight at time 3, then we would have to double stack. So we're not going to do that because that makes my head hurt. We're just going to do normal log, multinomial log. Okay. So just go with changing the dataset name and then the diagnosis. I'm sorry, the DV here. All right, let's run that. So now I should have what I have in the notes here. So if we sorted diagnosis, we would see all the trues would be the original rows. And it just added a bunch of rows with falses and repeated them. Go back here. So the next part, not so different. Okay. So you would say mlogit for multinomial. DV is approximately, that's a 1, and then a pipe. It's technically what that's called. The straight up and down one. It's called a pipe. This implies that it should have an intercept. We've never had to do that before. You could have, but we haven't had to do it. In this particular model, they force you to put it in there. Because if you leave it out, you get a different model together. Okay, so you don't change that. Leave the 1 pipe stuff. And then you change the name of the IDs. So I've got my diagnosis is, give me an intercept plus weight, fast, binge, so all of these. Data equals dataset, okay, our new long data. And then ref level equals whatever reference you want. If I left that out, it would automatically give me the first one alphabetically, because it imported that way. But I included it so you could change it if you wanted to. That's all the weird new stuff. The rest of this should be moderately the same. So you should get this giant output. As the first part of the output, it actually gives you percentages. So if you forgot to check if the ratio of cases was okay, that's in proportions. So this is going to be hard because 20%. The unfortunate amount of output in not so pretty format, giant code here. But the first question is always, is my model significant? These pins. So is the model significant? Well, we talked last time about null models versus residual models and how you had to do this chi-square comparison. But as hard as they made you work to set up the data, they at least gave you the answer without having to compare. Okay, so the lights in the hallway just went off. It's like really creepy. Hey guys, that means no one has walked down the hall in like, what, 20 minutes? Anyway, squirrel, sorry, it was in my vision, so I was like, what just happened? Chi-square, okay. How do I know what goes here? That fortunately is easy, just count. Okay. So how many of these lines do you have? Well, 16. Okay, actually it might be 18. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Sorry, I can't count. Yeah. Okay. So that's what goes there. The number of lines. P is less than 0.001. You get a version of pseudo r squared. We get McFadden's. So we're just going to include that because why work hard? Also, that pseudo r squared thing we learned last time doesn't work for this package. So that's a pretty good r squared. Remember, 0.25 is large. Okay. So we have a large effect. So yeah, my model's significant. So the hard part is just figuring out this, and it's just count the number of predicted lines, including the intercept. All right, so I got that here. And then let's make a table. Yay, Erin loves tables. Okay. So if I look at the predictors, what's going on? Well, for each comparison, so anorexia versus both, anorexia versus bulimia, it gives me each variable one at a time. So what's happening is, instead of giving you, here's all of both, here's all of bulimia, it just kind of rotates them back and forth. So it kind of looks like dummy-coded output. Right? So this is the one for the dummy-coded DB, and here's the IB. But you interpret them the same way. So let's see, for weight, the first one's not significant. So again, this both category doesn't matter. So the distinction between these two doesn't matter, like weight isn't a predictor. For bulimia though, weight is significant. And it's positive. So that means it's going to be the reference cat. This is the second category. Okay. So this one here is the 0 or reference. This one here is the 1 or second category. So we made that table last time of like the one on the left is going to be for negatives and the one on the right is for positives. So any negative predictor goes for anorexia, any positive predictor goes for both of these. So for bulimia, the weight, so more weight, you're more likely to be in the bulimia category or more concerned about weight. So this is the bulimic group. Okay, let's see what's next. We did weight. Fasting doesn't predict here. But it does predict in the bulimia category, but not in the direction you would expect. So if they perceive, it's like perceived need to fast, they're in the bulimic category. So if you think about this as like their perceived like obsession with it, it might make sense. Because this is bulimia after anorexia. So they've kind of been treated for it and now they have bulimia instead. So maybe they're thinking I shouldn't be eating. Yeah. Only way I can think that making sense. Otherwise, it seems backwards. Okay. Binging, nothing. We'd expect it to predict here, but it doesn't. So not significant, not significant. Vomiting's the same way. Purging, but not in the direction you'd expect. Again, it's kind of backwards. So in both categories, it predicts the anorexia group. This is negative. Don't know why. My data isn't always perfect. So both of them, because they're negative, predict the lower coded group, which is anorexia. And in both of them, they have higher purging concerns. Hyperactivity is sort of marginal. It's close. That's what the little dot means. So, and it's positive. So it's both here. They're more hyper. Non-significant here. And then preoccupation with body weight, also marginal. So for both, it's non-significant here. And then body is nothing. So that's kind of what I tried to do here. Oh, I left body. Oh, I screwed this up a little bit. Here. So preoccupation with body weight is both. I think I skipped a line, right? Yeah. So more preoccupation equals higher probability of both. And it's actually body that is non-significant. That should match. So I just interpreted them as well in the table. So more purging is a higher probability of anorexia. So I'm interpreting those the same way we did before. It's just there's two of them now. If you have 4 groups, there'll be 3. So that's why I said multinomial, don't do too many groups. Because you're just going to keep getting more and more categories. For heaven's sake, don't do 4 with small sample sizes. All right, so from there, excuse me, how many did we get correct? So there's a lot of non-significant variables. There's only a couple that were useful, but it's a big effect size. So what are we getting right? And I bet what we're getting right is the anorexia group because they're the largest group. So the quick reminder is this is not a 50-50 shot anymore. There's 3 categories. 33% is chance. So if we're just doing better than 33%, we're actually doing significantly better than chance. All right. What we can do is pull the probabilities. So let me just type them real quick. Model probabilities. So you don't have to do that. I'm just showing you where I got these numbers from. Instead of saving a probability of group 2, it saves the probability for each group because since there are 3, it would be weird. The probability of group 2 twice. So what happens if it's low on both of them or if it's high and low? So it pre-calculates for you a probability of each group separately given the equation numbers. Which is nice, because then you don't have to figure out like double weird classification schemes. Right, so if this one said it was both, but this one said it was anorexia, what would I do? And so it's got the probability for each group separately. And what I want to do is for each row, pick the maximum probability and then assign them to that category. Okay. So for the first row, it's really easy. That clearly 97% it thinks they're going to be anorexic. But when you get down towards the bottom, and that's the part I cut and pasted into the notes, not so clear. Right, so some of these rows, it's like 37, 24, and 37. So it's very close. So 182 especially is 37.8 and 37.7. So those are the people that we talked about as a 50-50 shot being like, whoa, yes. That's kind of similar. What happened, okay, so what I did to actually get those classifications is I think line 39 for you guys. Okay, so I saved them as a separate little data thing because we're going to use it a couple times. And then I called it binary correct again, although it's not really binary. But that disgusting look piece of code, what it does here, so start here. Apply is very similar to tapply, but for each row, it calculates something. So we've been using apply to calculate percent correct for participants. Now we're using apply to figure out which one is the max. So which max is, which column is the max. And we've actually been using column names when the data set doesn't import correctly. So it's a combination of like two things that we've used before in the thank you Stack Overflow for answering that question. How do I figure out column names? So it figures out which column is the max, 1, 2, or 3, and then it figures out the column name that goes with that. Okay. The only thing you would have to change is if you decided not to call it correct. So as long as it's called correct here, it'll be fine here. And then I made a table. So the table is of the original. This is the original. Under here, under binary correct, this is the predicted one. So down the side is the original here, and then across here is what it would have predicted. And so this middle diagonal here is correct. So anorexia, that would be our percent correct. 8, so we got 8 right. I'm not doing very good. And 29. Okay, so remember where they line up is what you got right. Our bad battleship example. And then I forgot to change these to the real numbers, but I have them in here. Okay. So to calculate the percent, it's the correct over the total for that row only. So I'm getting 95-ish% right for the anorexic group. A little bigger, sorry. And then less than chance at both. Okay, so we're doing pretty bad at the both category. And then 50% of the bulimia group. But it's not too surprising if you look at all the non-significance. So in this both column, and these are marginal, so they're not the best predictors. There's not a whole lot going on. Of course, this one only has 3 of them as well. And that's why the ratio of cases is so important. It's really hard to predict the smallest group. And then to get the overall percent correct, you could just average those together, or I could do all of the corrects over the total. And that's 68%. Notice that this in row is of the original data set. Don't do it on the long data set. It tripled the total. So that is on the original data set. We have a big R squared because this is testing if we're better than chance. Chance is 33%, so yeah, we're better than chance. But the other group, the both group is really bad. The reason we're doing so well is because the anorexia group is nearly perfect. So I don't know that I would call that a win, right? All right, so, and then we did some cool dot plots. The issue with the dot plots on this one, explanation, God, spelling, is that, let's look at one. I can't just do like probability on the bottom because I have 2 of them, right? And then the way it calculates probabilities for you is the probability of each group. So what I did was I separated it out and just did the probability of each group separately. And so the code didn't really change. I did change the theme coding. I finally figured out why the X and Y lines went away. If you've updated recently, you can't get the X and Y axis lines anymore. That's because they updated something and broke my code. I did finally fix that. So this theme coding will fix it. All right, so I switched correct to a data frame so I could use it the way I wanted to. So what are you going to change? Change the name of the data set. This should be the original data set. Master here. Here, under aesthetic, pick what group you want. Okay, so I did anorexic first. Under color and fill, put in the diagnosis. So it's going to give me the dots colored by which group they actually are. And it's giving me the percent likelihood of being anorexic. And then the rest of the code stayed the same. except I added more colors because there's 3 of them. Make this bigger. Whoa, it's really big. So it's got the likelihood of anorexia on the bottom. The blue dots are anorexia, so we want all the blue dots to be over here. So what you're really looking for in this plot is these blue dots. We're doing a really bad job of getting them right. So this is the outliers in the solution. So you're looking for dots that are very far from where they should be, which is all the way over here. Now you could use 33% as a cutoff, but I think it's almost easy if you don't have one. Like those 3 on the end are really bad. To get the other 2, all I did was change this here. Okay, it should, there we go. Both. I also changed the X and Y axis labels, but that's too much work. So now I've got both, ignore the bottom. So you see all the blue dots from over here? That's good. Because I put the likelihood of both. So both is green, and we're just doing terrible. Look at them, they're all over here. And so these are probably a couple of green dots we got right. And then last one. And let's see. What about the red dots? Well, clearly we're doing a little better. There's more red dots over here, but these are the red dots that are not so good. The higher your percent classification, the more they'll be on this side. Okay, the lower your percent classification, the more they'll be kind of spread out. All right. So I put all 3 of them, and I put the right labels in here. Likelihood of both, likelihood of bulimia. So it's still the same setup. I have to ask, is my overall model significant? Are my predictors significant, and how, this table, and then make a plot. Okay. Oh, correct, percent correct, and plots.